Yes, I work in the area of organic synthetic chemistry. I'm an professor of organic chemistry here. And typically what we do on the average would be considered to be synthetic organic chemistry. Basically, we design and build things. So molecules that might be anti-cancer agents or antiviral agents, and they might be even compounds that would be embedded in plastics to give them special characteristics. We've had long-standing collaborations with biologists, Mark Nielsen-Hamilton, who's across the street in molecular biology, Wendy Morey, who's a virologist at the University of Iowa, and more recently, Brent Shanks, who's a chemical engineer here at Iowa State, and Eric Cochran, who's a polymer engineer here at Iowa State, and Joel Snow, who's basically working in entomology in the biology area. So these are people with whom we've had active grants and with whom we have active collaborations involving our students. In fact, I'm part of a center called the CBERC, the Center for Biorenewable Chemicals. And that's a group of about 25 faculty across the US. And we're looking at making renewable materials and using those renewable materials to have good characteristics. For example, if you're thinking of developing alternatives to petroleum-based materials, you would really like to have a material which is superior to the corresponding petroleum-based material, so people have a real incentive to want to use that and wean them off the petroleum base. So we're looking at a number of compounds that are corrosion inhibitors. Corrosion is a big issue across the world. You can just see if you have a car that's 5 or 6 years old, there's plenty of corrosion. But that's even more true in oil fields and a variety of other areas. And so we're developing materials that come from natural sources that can inhibit the process of corrosion. And that's a collaborative grant, not only with myself and Brent Shanks, but also people from University of Washington and also Northwestern. We have a project going with Eric Cochran on wind turbine blades. Believe it or not, these wind turbine blades that you see all across Iowa are very difficult to deconstruct. In fact, you can find places in Iowa where there's just piles of wind turbine blades that people don't know what to do with. So we're looking at using some of our renewable polymers to apply them to aspects of wind turbine blades such that when the life of the blade is over, we can then break apart our polymer, which then makes it easier to break apart the rest of the components in the wind turbine blade. So I think that's something we've just submitted a grant to the Iowa Energy Foundation for a grant for that. But in general, the idea of building small materials, embedding small materials inside polymers such that at the end of life of the polymer, you can deconstruct it back to the simpler components it was made of. One thing they gain is just exposure to a wide variety of different reactions. They'll have it when they're finished and graduating, they have a repertoire successfully running, dozens, if not hundreds, of different reactions, which is going to be useful because you never know where a synthetic chemist is going to wind up. But even more so, since we have so much collaboration, they learn to function as part of an interdisciplinary group. For example, every one of our projects right now has interactions face-to-face or via Zoom with our collaborators every 2 weeks. So you'll meet Alexei in a little bit, and he's part of the collaboration here at Iowa State. We also have researchers from 3M and ADM, Archer Daniels Midland, as part of the team as well. So we meet every 2 weeks and talk and just understand better the processes and how the project's going and so on. But it's a good exposure for the student to meet people from industry as well as interact with people from other departments. One of the best parts really is that there's such a low barrier to collaboration. It's so easy to go out to lunch with somebody or go to coffee with somebody and talk about a project and work with them. Believe it or not, that's not true in most of the universities across the U.S.